All right, welcome to lesson 1.6. We're talking about transformations of functions. So, things that will slide a translation, things that'll slide the function up, down, left, or right, things that will flip the function reflected across either axis, or stretch or compress the functions. The first thing we're going to talk about are what are the functions that we're going to do all those things with. Let's look at the objectives. So we're going to first, again, recognize graphs of common functions. So we're going to go through a list of all the functions that we're going to do these things with. Vertical shifts and horizontal shifts, those will be the translations. Reflections, that'll be where you flip. Vertical stretching and shrinking, those will be multipliers, and same with horizontal stretching and shrinking. It's just a matter of where the multiplier is. And then we're going to graph functions that have a number of those transformations. So the first thing we're going to look at is just, here's the list of the basic functions. F of x equals c. C is a number, so that's going to be a horizontal line. We'll look at that. F of x equals x, that's a diagonal line, slope of 1 through the origin. Absolute value function, quadratic function, square root function, cubic function, and then cube root function. So let's quickly talk about each of those. F of x equals c is going to be a horizontal line through whatever c is. The domain of that function is all real numbers because it goes left and right forever. The range is just c, right? It's just a number. The y value will never change on that. And then the function is constant, right? It's not increasing or decreasing. And the function would be considered even. You think back to a couple lessons ago when we talked about even and odd functions. This is an even function. F of x equals x. The domain is all real numbers. The range is all real numbers. It's increasing the entire time, and it would be considered an odd function. Again, it's, the equation y equals x goes through the origin and has a slope of 1. Absolute value function, right? Domain is all real numbers. The range starts at 0 and goes up forever. The function is decreasing for the first half up to 0, and it's increasing from 0 all the way out to the right forever. And it would be considered an even function. Quadratic function, f of x equals x squared, is going to have all the same characteristics as the absolute value function. Domain is all real numbers. The range starts at 0 and goes up forever. It's decreasing for the first half, so up to 0. And then it's increasing for the second half, so starting at 0 and then to the right forever. It's also an even function. Square root function. So f of x equals square root of x. The domain for this starts at 0 and goes to the right forever. The range starts at 0 and goes up forever. It's increasing the entire time, but it's not all real numbers. So it's increasing from 0 and up, and it's not even or odd. Cubic function, so f of x equals x cubed. Domain is all real numbers, range is all real numbers, and the function is increasing the entire time. It would be considered an odd function. And then the cube root function, basically same deal as the cubic function. Domain of the function is all real numbers, range is all real numbers. It's increasing the entire time, so all real numbers, and it is an odd function. Next thing we're going to talk about are vertical shifts. So whatever the generic function is that we just talked about, so whichever one of those that we apply this to, if you add something outside the function, so if we're talking about an absolute value function, we're talking about adding a number outside the absolute value bars. If you add a number, it goes up. If you subtract a number, it goes down. And it's that basic. So we're going to look at f of x equals absolute value of x. That's the basic function, also known as the parent function. If we compare it to g of x, which we've defined here as absolute value of x plus 3, the plus 3 will shift it up 3. So the blue is the basic absolute value function. The red is the g function. The plus 3 simply moved it up 3. So it's the exact same shape. The vertex just moved up 3, so the entire thing moved up 3. If that was minus 2, it just would have gone down 2 from the blue function. Now let's talk about a horizontal shift. This is when you're adding or subtracting something on the inside. Plus on the inside moves it left. Minus on the inside moves it right. That might be counterintuitive because you think on a number line, positive is right, minus is left, but it's, again, I think it's counterintuitive to the reaction to the function. So again, adding on the inside, left, subtracting on the inside, right. And again, when we're talking about inside, if this was an absolute value function, we're talking about inside the absolute value bars, adding or subtracting, as opposed to what we looked at for vertical shifts, which was outside. This is inside. So now we're going to look, the example is going to be a square root function. So f of x equals square root of x is the generic basic function. The minus 4 is happening on the inside of the absolute value bars for the g of x. So it will be the exact same shape, and it will shift to the right 4. Minus 4 on the inside is right 4. All right, so that's the basic square root function graph. And it was moved 4 to the left, 4 to the right. Apologize. It is the same shape, even if it doesn't appear that way on the graph. If that was plus 3 on the inside, it would have moved to the left 3 as opposed to the right. All right, reflections. If the negative sign is on the outside of the function, so for instance, if we're talking about a absolute value function again, the negative sign would be on the outside of the absolute value bars. That's going to reflect it about the x-axis. What that means is it'll flip upside down. A reflection about the y-axis means is created by a negative sign on the inside of the function. So the negative sign would be inside the absolute value bars. That would flip it across the y-axis, which actually would have no effect on an absolute value function. Maybe something like a cubic function. So you'd have parentheses, the negative would be on the x on the inside of the parentheses, the exponent would be on, the exponent of 3 would be on the parentheses. That would flip the function across the y-axis. So think about how that would look. We're going to look at the example of a cube root function. So the basic function in blue is just the cube root of x, and that looks like that. For the red function, h of x is the cube root of negative x. The negative's on the inside, so it's not flipping it across the x vertically, it's flipping it across the y horizontally. Okay, so there it is, it's flipping across the x-axis, but horizontally. All right, stretching and shrinking the graph. Okay, so this is a multiplier. So something on the outside of the function is multiplying. It's vertically stretching it if the multiplier is more than 1. It is vertically shrinking it if the multiplier is between 0 and 1. We don't think about vertically stretching or shrinking as like a negative number because the negative would be doing the flipping. So if it was like -3, you would look at the vertical stretching as the 3. The negative part would then be flipping it. So we only think about it that way. Also notice how 1 is not included here. If the multiplier was 1, it would have no effect, right? It wouldn't be shrinking or stretching, it would just stay what it was. So again, a multiplier that's more than 1 will stretch the function out, and a multiplier that's a fraction less than 1 will shrink it. So in this case, the multiplier is 2. And when we talk about a vertical stretching, it's going to get higher faster. So the effect will almost look like it's getting skinnier as opposed to getting stretched. But again, that would be your absolute value function. And then g of x equals 2 absolute value of x. Again, it looks skinnier because it's getting taller faster. Horizontally stretching or shrinking is when the multiplier is on the inside. Almost has the opposite effect. So if the multiplier on the inside is more than 1, it's going to shrink it horizontally. In some texts, or if you look online at other resources, you might see shrinking, also known as compressing. Okay, if the multiplier on the inside is less than 1, so a fraction less than 1, it's going to horizontally stretch it, so it'll actually, in effect, get longer. All right, so graph using a sequence of transformation. So obviously, all these things can get combined into one. So we've gone through all the different types of things that can happen: the translations, which is the shifting, the reflecting, and then the stretching and compressing horizontally and vertically. So when I would look at a function like this, I would say, all right, first of all, g of x equals 2 times x minus 1 squared plus 3. I first recognize that's a quadratic function. So its basic shape is going to be the same as f of x equals x squared, just with those things added into it. The plus 3 on the outside is going to move it up 3. The minus 1 on the inside is going to move it right 1. And then the 2 multiplier on the outside is going to vertically stretch it. So you start with your quadratic function, you move it up 3, then you move it right 1, and then you stretch it vertically. Okay? And that would be the comparison between the basic parent function of f of x equals x squared and the graph of g of x equals 2 times x minus 1 squared plus 3. All right, so at this point, you're going to go ahead and try some of these on a Math Excel practice. The 1.6 practice will be posted by the time you're done taking the notes. Obviously, reach out with any questions. We'll have the rest of the day today and then tomorrow to work on the practice. Let me know if you have any questions.